these expressions of velocity and acceleration using the calculus method also. Like when the body is over here and light is falling from here, we are looking at the projection of this motion onto screen. So we say y is equal to r sine omega t. Now we have to see that is how this y is changing, that is dy by dt we are interested in. So velocity along y axis is going to be d by dt of r sine omega t. R is constant, it comes out. So it is d by dt of sine omega t. So this is Vy. So Vy is equal to R of this is sine omega t is, that is cos omega t into d by dt of omega t. So this comes out to be R cos omega t into d by dt of omega t is omega only. So this comes out to be R omega cos omega t. So this comes out to be R omega cos omega t is once again can be written as 1 minus sine square omega t. So this can be written as omega, we take r inside, r square minus r square sine square omega t. So this comes out to be omega r square minus y square. The same result, be it over here r omega cos omega t or this one, which we have got without using calculus. And in case we are interested in the acceleration, so once again we can differentiate it to get the acceleration along y-axis. So acceleration is going to be d by dt of r omega cos omega t. So this comes out to be r omega is constant, comes out r omega d by dt of cos omega t. So the acceleration comes out to be r omega cos omega t is minus sine omega t into d by dt of omega t. So this comes out to be, this is going to be what? This is going to be omega. D by dt of omega t is going to be omega only. Omega and omega. This is going to be omega square. So it is going to be minus r omega square, minus I have taken out, sine omega t. So this comes out to be minus omega square r sine omega t, and this comes out to be minus omega square y. It is once again the same expression which we have got even without using the calculus method.